So they give you function f right here. They give you values for g and g prime in a table, and then they give you h as a graph. So it's just an overload of information. Let's just try and look at one thing at a time. Find the slope of the line tangent to the graph of f at pi. All right, slope of the tangent line means derivative. So we want to find the derivative of x, and then we want to plug in pi. So we still have to do that, but at least the directions aren't something you have to interpret. Like it's pretty clear that's what you're supposed to do. Find the derivative, plug in pi. All right, so here's function f. We're going to do this derivative. Derivative of cosine is negative sine. So this will be negative sine of 2x. And then there's a chain rule. You have to chain on the derivative of 2x, which is 2. So I'm just going to put that out front. So it'll be negative 2 sine of 2x plus, all right, and then we have to do the derivative of this, which is also a chain rule. E is itself, so it's going to be e to the power sine of x. And then you have to chain on the derivative of sine, which is cosine of x. All right, and then we're going to plug in pi. Now for free response, you do not need to simplify it down. So you can actually just leave it like this. I kind of feel like you should know what sine of pi and cosine of pi are, but they can't fault you for that. So you can just leave it alone. So that's it for part A. So find the derivative, plug in pi. All right, letter B, let k be the function defined by this, h of f of x. So that is a composite function. This is going to be a chain rule. You have h of f of x. It's like h got hungry and ate function f. Find k prime of pi. All right, so again, we're going to find k prime of x, and then we're going to plug in pi. All right, so actually really similar to what we just did there. All right, k prime of x. Derivative of the outside, so that's going to be h prime, leave the inside alone. So h prime of f of x. And then you chain on the derivative of the inside stuff, so f prime of x. So h prime, leave the inside alone, and then chain on f prime. And we're going to plug in pi. All right, so we want to find h prime of f of pi. So here's function f. We'd want to plug in pi. Now, like I was just saying, you can leave these alone. I actually am going to simplify some of this down for a second, though, because otherwise you'd have to write cosine of 2 pi plus e to the sine of pi. I don't want to write all that. Let me grab my unit circle and we'll just actually sort this out. So I don't want to have to write all that. All right, if we plug in pi here, 2 pi is the whole way around. Cosine is the x value, so that would be 1. So this first part would be 1. Sine of pi is right here. Sine is the y value, so that's 0. E to the 0 power is 1. So we'd have 1 plus 1, which is 2. So that'll be h prime of 2, and then times f prime of pi. So again, we're still plugging in pi for x. I'm not done with that unit circle. I think I'm going to have to simplify more of this down here. All right, h prime of 2. Here's our graph of h. Derivative means slope. So we want the slope at 2. So here's 2. We want the slope at that point going down 1 over 3. So that'll be negative a third. So this part's negative a third. And then we want f prime of pi. Well, here is f prime of pi. I said, yeah, you don't need to work this out. And technically you don't. You could just copy all that over. But you know what, for the sake of writing this out, let me actually just go ahead and evaluate this. Also, it won't hurt you to know the unit circle. All right, again, 2 pi is the full way around. That's right here. Sine is the y value, so that's 0. So that first part's just 0. Sine of pi, again, is 0. E to the 0 power is 1. And then cosine of pi, cosine is the x value, so that's negative 1. So actually, that whole thing comes out to negative 1, which is not too terrible. And so negative a third times negative 1 will be positive a third. So positive a third for this one. Again, they can't fault you if you stop here, but we ended up needing that in the next part, and it was just going to be real tedious to write that whole thing. So I just went ahead and simplified it down. All right, I'm going to have to fold the paper over so we can see part C here. All right, so part C, let m be the function defined by, and then they give you this m of x. Find m prime of 2. All right, again, we're going to find m prime of x, and then we're going to plug in 2. This is like testing all of your derivative rules here. So this is going to be a product rule. This is our first function, and this is our second function. All right, so we have the first function, g of negative 2x, times derivative of the second. So that is h prime. So first times derivative of the second. plus the second function times derivative of the first. Now that's another chain rule. It would be g prime of negative 2x, and then you have to chain on the derivative of negative 2x, which is negative 2. Right, so derivative of the outside g prime of the inside stuff, and then chain on a negative 2. So that's your derivative. Now we're going to plug in 2. All right, goodness. All right, if we plug in 2 for x, this would be g of negative 4 h prime of 2 plus, or actually, this would be a minus. Let me put that minus 2 out front, because we have a negative 2 times this whole thing. Minus 2 times h of 2, and then g prime of negative 4. Again, if we plug in 2 for x, that'll make that a negative 4. All right, so now we got to go find all these. G of negative 4. Let's see, they gave us g in this table. It's like scavenger hunt. You have to find everything. G of negative 4 is 5. And then h prime of 2, we found that already. That's the derivative at 2. We said that was negative 1/3, right? Oops, I wrote a half though. So negative 1/3, and then minus 2 times h of 2. Right, so here's h of 2. We want that point. So if we start at 0, we're going down 1 over 3. If that's at 2, that would be a negative 2/3 for that. So negative 2/3 at that point, and then g prime of negative 4. So here's my g prime column at negative 4. That is negative 1. And again, you can simplify that down if you want, but you're totally allowed to stop there. All right, was there a part D for this? Oh, no. Oh, another one, more fun. All right, letter D. Is there a number C? Oh, this sounds like one of our theorems here. Is there a number C on the closed interval such that the derivative equals negative 4 justify your answer? All right, did they tell us that this function is continuous and differentiable? Did they tell us G? Yeah, G is differentiable. All right, so that we're gonna have to bring that up. This is going to be mean value theorem. So we need to find 2 points on there where the slope would be negative 4. And I know this says g prime, that's the derivative would be negative 4. We need to just look at this column. We need to find 2 points on there where if we did the slope, it would come out to negative 4. So let me see. Oh gosh, which 2 points? I think it's going to be, let me see. Let's try the negative 5, 10. I worked this out earlier. Let me see what it look back at my notes. Negative 5, 10. Yeah, and then negative 3, 2. That's what I was going to say. If you take those 2 points, and I don't like that. I feel like they make you figure out which 2 points it is. I feel like they could, at least tell you the correct interval. But anyway, if you take those 2 points and slope them, you'll have 2 minus 10 over negative 3 plus 5. That's going to be negative 8 over 2, which will give you negative 4, which is what they said. Is there a value C somewhere in there? We had to figure out which 2 points to use, where the slope would be negative 4. So the saying derivative equals the slope. So it's mean value theorem. So the answer is yes, since g of x is differentiable, it is also continuous for good measure here. So by mean value theorem, and you can abbreviate that, and then you can just repeat what they said. By mean value theorem, there is a number C on negative 5 to negative 3 such that g prime of C equals negative 4. So once you say the conditions of the theorem, continuous and differentiable, and once you show this slope, say mean value theorem, it's just a theorem you're citing there, and then you can just recopy what they said in the problem. Basically like turn their words on them. Again, I think you're going to be doing a lot of this because they're having you type answers in this room. All right, so points for this. Part A, they said 2 points for the answer, which leads me to believe it's 2 points all or nothing, which feels unfair. I feel like they would probably give you 1 point for the derivative and then 1 point for the answer. They would probably break it into 1 and 1 there, but sometimes they don't. So, you got to be careful. All right, part B, it is 1 point for the derivative and then 1 point for the answer. And then part C, it is 2 points for this derivative, which is fair because you had to do a lot there. 2 points for that, and then 1 point for the answer. So let me see, what am I at so far? 1, 2, 3, 4, 5, 6, 7. So there should be 2 more points for this, and there's a point for doing this slope. So if you figure out which 2 points to use and then do the slope and show that it's -4, and then a point for writing out your explanation, which those are tough, but I think we do need to practice those a lot because I feel like they're probably going to do that to you a lot this year.